With our process still over here to the right, let's make a similar attack at the rate question that we made to the payment question. In the payment question, it took us an additional payment to earn that $1,000 in the future because our rate was only 10%. Well, let's imagine that you had $100 invested today and you wanted it to grow into $1,000 in 10 years, but you couldn't make that additional payment, and instead you need to earn a higher rate of return. So reading that problem twice, let's move on to documenting our assumptions. And we can see when we document our assumptions, again, I have a present value of $100 that I wish to see it grow into a future value of $1,000. I have a number of periods that, again, for this is in years, it's 10, but I'm not sure how much my rate should be. So with those things documented, let's add a little breaker line in here so we can attack the problem. And again, it's going to be present value, future value, payment rate, and time. I have a lot of those. So there's present value. I'm copying that one down. Future value. Here's payment. I need rate. And then I need time. Well, I already have my number of periods listed as annual, and I know that I need to make these all into synchronous periods. So chances are then this rate is also going to need to be annual. Now look at something here though. If I try to double click and make that into annual, it doesn't quite work down below because it's actually a formula. So if I do it this way, I'll actually have to qualify my rate up here so that when I pull it in down below, now it grabs that term. But payment, since we just typed it in, I can go ahead and requalify that as annual down here. Now, when we get to present value, I'm going to encourage you again to think of investments as cash flows out now, which means a negative number. So the reason I say that is this time I'm going to do equals negative because the present value of 100, I want to grow that into 1,000, and I have no payment. So I'll just type in the 0, make sure I format these as dollars. And this time I'm looking to solve for my rate. So let's highlight that and put it in bold. And my number of periods is 10. Let's go back to the quicker way to do it, which is equals rate when I'm doing step 3, use Excel formulas and functions. And then it asks me my number of periods, and I can click on number of periods and then comma. And now I can actually use my arrows if I'd like. So I can find payment, comma, present value down below with the negative, not the one up top because that one's shown as a positive, comma, then the $1,000, and I don't need to do type. And Excel's smart enough to know I can just hit enter, and it tells me that that's 26%, which is a pretty significant amount of a rate of return, which is my interpretation of these numbers. But my presentation of the numbers too, I probably want to add a few more decimals on there because oftentimes when we talk about rates, we talk about 2 digits past the dot decimal there. So the answer for this would be if I wanted $100 to grow into $1,000 in 10 years and I wasn't able to make an annual payment, I would need to earn an annual rate of return of around 25.89%. And that's how you work with the rate function for time value of money in Excel.